There's another question I want to do. This one. All right, let's do this one then. Recording. Okay, so here's another example. So here, this came from the book. This is where it is in the textbook. Marie, okay, she can afford a $250 per month car payment. And she can get a loan at 7% interest for 5 years. Okay, so in other words, she's getting a loan basically to buy a car, and to pay off that loan, we're told that she can make $250 a month. You know, she can afford that. And the loan she can get, you know, from the bank or whatever, it's 7% interest for 5 years. That's 7%, oops, sorry. Press the escape key by mistake. It's 7% interest for 5 years. So the question is, so we have these questions, how expensive of a car can she afford? Really what they're asking is, what is the biggest loan amount or the largest loan amount she can get? You know, how big of a loan can she get? In other words, we want to know what P0 is in our formula. That's what we're looking for. And then we have these other two parts, you know, how much total money she'll end up paying the loan company and how much of that money is interest. Right, so again, for how expensive of a car can she afford? Well, that's what the loan is for, right? So they're really asking, what is the largest loan she can get? In other words, what is P0 from the formula? So that's our unknown. We're told that PMT, she's making payments, that's $250 a month. The interest, 7% interest, that's 0.07. She's making monthly payments, right? So because she's making monthly payments, okay, that tells us there's 12 compounding periods in a year. Remember, the number of compounding periods in a year is the same as how many payments is made a year, or withdrawals, depending on the context. You know, here we're dealing with a loan, so it's the number of payments. So the number of payments she makes a year, which is 12 because she's making one per month, there are 12 compounding periods. And T is 5, it's a 5-year loan. So this is our formula. So we want to substitute then, and again, P0 is what we're looking for, right? P0 is the loan amount, you know, the size of the loan. Or if you want, I guess to be more technical, it's, you know, you're paying off the balance of the loan. It's the initial balance of the loan. That's a little more technical, but I think everyone understands what I'm trying to say. So we can figure out what P0 is. So I substitute all the variables, right? We substitute, and now we calculate. And again, what I would do first is 0.07 divided by 12. You know, you could do that in the denominator, right? This is rounded actually, because it's a what do you call it? It's a repeating decimal, non-terminating, as they say. So I'm using 7 decimal places. I do the same thing up here. Now for order of operations, right? We're going to work from the inside out. That's what we're going to do here. So we add, that's what we get down here. What I also did at the same time was I carried out this product, negative 12 times 5, that's negative 60. We added as well. Then we actually carry out this product, you know, we take, not product, excuse me, this, we take this and raise it to the negative 60 using a calculator. We get this, as you can see. Okay, so that handles this part. We do 1 minus that. That gives us this, as you can see. Just had to check something. And now what we're ready to do is we carry out the product and the quotient. So we do this whole algebra here. We do this big product on top and then the quotient, we divide. We end up getting this amount. That's what we end up getting. So that's how big a loan she can get. So she can get $12,625.51 from a loan company. That's how big a loan she can get. Hence, the most expensive car she can afford is one that costs this amount. It's a $12,625.51 car. Okay. Now, so we have the loan amount. Now again, she's making $250 monthly payments for 5 years. So we want to know, how much money is she sending to the loan company in total? How much is she paying them in total? Well, we take the monthly payment, right? We're going to multiply by 12 months per year, okay? And then we multiply by 5 years, right? You have to multiply by 12 months per year. This is in months, right? The payment. This is in years. This will handle this. This will handle months and years, just like that factor label method from the beginning. And this product turns out to be $15,000. She ends up paying them $15,000. Well, she's paying off the loan. Why is there more money she's sending them? That's interest. Anything above the loan amount is interest that she has to pay. Well, how much interest is there? It's how much she's sending them minus the loan amount, P0. And that's our interest. It's how much more she's sending. Okay. All right. Any questions on that? Because the next one I wanted everyone to try on their own. Okay. So the next one I want people to do. Okay. Okay. All right, so the next one here, this one I want everyone to try. It's actually the same problem. The only difference is that some of the numbers are different. Here, basically, we're saying Marie, it turns out, can actually afford a $300 per month car payment. So she goes to a different loan company, I guess, or whatever, and the loan she can get is at 9% interest, but now it's for 6 years long. It's 6 years, though. So now we answer the same questions, how expensive of a car can she afford? How much total money is she going to send them? I just want everyone to try this out for themselves, okay? Take about 5 minutes. So let me stop the recording.